right, today we are going to start Chapter 4. Chapter 4, the kind of pre-part of Chapter 4, that's why this is 0 kind of review before we get into the new stuff, is simplifying radicals. So some terms you need to know while simplifying radicals is, first off, that symbol is called the radical sign. It's like you're surfing radical, man. So that's our radical. A lot of times you say that as the square root or the cube root, but if you just have that symbol, that is called a radical. Next, our square root. Remember, square root means a number multiplied by itself 2 times to equal the radicand. What is the radicand? Well, the radicand is the number that's underneath the radical. So, for example, if I have this radical, the number underneath the radical is called the radicand, and the number right here is called the index. We also call it the root. So remember, if there's no number there, it's assumed to be a 2 or the square root. And lastly, our perfect squares. And to get our perfect squares, we can just take any number and multiply by itself. So 0 squared is 0. That is the first perfect square. 1 squared is 1 times 1, which is 2. Sorry, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. And again, there's an infinite amount of perfect squares because you can just take it, keep taking a number times itself. For what we're doing today, though, 0 and 1 are not going to be very helpful. Okay, so I'm going to kind of put a little X through them because these are the perfect squares that we're looking to see for simplifying radicals. So next, why do we simplify radicals? Because sometimes you want an exact answer when working with square roots, instead of using a calculator to find approximations, which are decimal values. So for example, if you type in the square root of 3 on your calculator, you're going to get an irrational number, a real long decimal, irrational number. But sometimes we want an exact answer, and the way we get exact answers is by keeping it as radicals. All right, so to keep answers exact, you need to leave square roots in radical form. All right, so here are our steps for simplifying radicals. Step 1 is you look for perfect squares as factors of the radicand. Remember, perfect squares factors are things that are multiplied together. So basically you're trying to figure out, can I divide that number underneath the radical, the radicand, by a perfect square and get a whole number out? That's ultimately what you're trying to figure out. All right, so if we look at our first example here, square root of 18. As I look at my perfect square list, I always start on the largest side. I always start on the right-hand side. You always look for the largest perfect square factor. And again, these numbers aren't because all these numbers are larger than 18. 25 is larger than 18. 16 is not going to go into 18. 9, however, it does divide evenly into 18. So that is my first step. I'm going to rewrite it. And then you're going to rewrite the number under the radical as 2 factors. So underneath the radical, I know 9 is my one perfect square factor, and 9 times what is 18? 9 times 2. So first step is just rewrite as square root of 9 times 2 all underneath one radical. Step 3, one of the properties of radicals is that if you have factors here separated by multiplication, you can rewrite the 2 factors as 2 separate radicals. Okay, so the square root of 9 times 2 underneath the radical is actually the same as the square root of 9 times the square root of 2. They are equivalent. So that's what we're doing for step 3 there. Then you take the square root of any perfect square factor. So 9 is my perfect square, and the square root of 9 is 3. And then I multiply the square root of the perfect square by the reduced radical. And so what does that mean? I took the square root of 9 and got 3. I'm then multiplying that by my reduced radical, square root of 2. So my final answer is 3 root 2. And what we do is we call this simple radical form. In simple radical form is the product, and again, product means multiplication, so product multiplication there, of a number, there's our number, and the remaining radical, there's our remaining radical, when there are no more perfect square factors underneath the radical sign. So underneath our radical, we have a 2. There are no perfect squares that divide evenly into 2, so therefore we know that is in simple radical form. So an example of simple radical form would be 2 times the square root of 3. 2 is that number in front, they're being multiplied together. There's no perfect square that goes into the square root of 3. However, a non-example would be 3 times the square root of 8, because I still have a perfect square factor that divides into it. 4 is a perfect square factor that divides into it. So then I'd have to write this as 4 square root of 4 times the square root of 2, which would be 3 square root of 4 is 2 times root 2, or 6 root 2 would be my final answer. That is simple radical form. This is not. All right, a couple other examples. For number 9, or number 2, square root of 9 is, if it's a perfect square, take the square root. Square root of 9 is just 3. Square root, for number 3, square root of 80. Again, I'm really looking at my perfect square factors up here. What divides into 80? So I start on my right-hand side. 100 is too large. That's too large. That doesn't go into 80. 49 does not. 36 does not. 25 does not divide evenly into 80. 16, however, does divide evenly into 80. So I'm going to rewrite square root of 80 as the square root of 16 times the square root of 5. And notice how I kind of skipped this step. You can write that step if you want, where it's all underneath one radical, but you can also write it into 2 separate radicals right away if you'd like. And so then I end up with 4 times the square root of 5. And there's no other perfect square that goes into 5. So So the one reason I said always start on the right-hand side of your perfect square list is you want the largest number, largest perfect square to divide into it, because it's less work later. Let's just say you're like, oh, I know 4 goes into 80, and you wrote it as the square root of 4 times the square root of 20, because you know 4 goes into 80 20 times. And then you rewrote this as 2 square root of 20. However, if you look underneath that radical, there's still a perfect square factor there. 4 still goes into 20. So then you'd have to repeat the process again. Square root of 2 times the square root of 4 times the square root of 5. And then you'd have 2 times the square root of 5, or 4 root 5. So notice if you pull out the largest perfect square factor right away, it's a lot less steps than if you don't. So that's why I would say start on the right-hand side of this perfect square list and work your way down. All right, 5 times the square root of 9. So again, 9 is a perfect square, so I just write this as 5 times 3, because the square root of 9 is 3, and then multiply those together, 15. 3 times the square root of 98. So again, what perfect square goes into 98? We start on a list. 100 does not, 81 does not, 64 does not, 49 does go into 98 2 times, however. So I'm going to rewrite this as that 3 staying in front times square root of 49 times the square root of 2. 49 times 2 is 98. Both have to be underneath radicals. Then I go ahead, square root of 49 is 7. And then I multiply my 2 coefficients in front. 21 square root of 2. And last but not least, if you have a fraction, you can take the square root of the top and the square root of the bottom. Just so happens these are both perfect squares, so the square root of 4 is 2, square root of 25 is 5. So 2/5 would be my answer here. On the back, I would like you to try those 3 on your own. And then, so for number 1, 4 is the perfect square that goes into 8, so it'll be root 4 times root 2, or 2 root 2. For number 2, 9 is the perfect square that goes into 54. So I had that 4 in front. Square root of 9 times the square root of 6, because 9 times 6 is 54. 4 square root of 9 is 3 times root 6, or 12 root 6. And then number 3, I have the square root of 9 over the square root of 49, which would be 3 over 7. All right, that's the basics of simplifying radicals.